Welcome back everybody, High Tech Lab here. Today I have a new module for my Click PLC from Automation Direct. This is model number C0-04THM. This is a analog input module, actually called a thermocouple module. I have the power disconnected to my PLC. It's in stop mode, powered down. Today I'm installing this module, and as you can see, all I gotta do is click it into place and close these two locking mechanisms, and I can now go ahead and turn the power back on, closing the fuse, and put the PLC in run mode. The reason I added this module just now is because here I have a shunt, and this shunt, as you can see, is pretty beefy. It's a, let me get this right side up, 50 millivolt deltec 2000 amp SWE109 is what it says there. This was provided by Chris Bowden. His channel is youtube.com/physicsduck. So that's where I got it from. He gave it to me. He's not a company or anything, but just a fellow YouTuber I'm a big fan of. And anywho, I have this connected with some wire I also purchased from Automation Direct. This is two pairs. It's shielded, so you can see I have black, red, and a silver. The silver is the shield. And over here on this end, I just have the shield wound up and the black and red connected onto the shunt. And on this end, the shield is going to be connected to the common port here on the input module. So pretty much I'm going to have TC minus is black, or I mean, my bad, TC1 minus is black, TC1 plus is red, and common will be the shielding. And that's going to be installed per this wiring diagram you can see here on the screen. This is out of the cut book for this input module. So here we are connected like I showed you just now, and we go through our wire, and again, this is shielded, so any interference it'll kind of cut out. Now we have my shunt, and what I can go ahead and do with this shunt is I can go ahead and take this and install it with some bolts on this bus bar, and just take a slit cut out of this bus bar and install it right there, and fish my sense line through this 2-inch conduit up above through the wireway, up, over, down, come through this bottom wireway and up in through this hole. I may actually come through this hole, I'm not sure yet, but stay away from some of the other interference. Come up, across, and I'll probably move this input module to somewhere in here. I'm not quite sure yet, nothing's set in stone, and that'll allow me to measure amperage with my PLC. So what I went ahead and did was I took some Sharpie and made some black marks here on this bus bar. Now I'm going to take one of my Milwaukee clamps. This is all plastic, and I went ahead and clamped this shunt on there over top of the Sharpie marks. So that way what's going to happen is I'm going to take a screwdriver, this guy right here, this little flat head, stick it in the holes, and go ahead and give it a whirl around to try and scratch out that Sharpie on that aluminum bus bar. And what that's going to do is that's going to leave me a permanent mark, so that way I know where to drill my holes. It's similar to a bluing agent used by machinists all the time to do their layout on where they're going to machine their part. So I'll go ahead and scratch the center of this bus as well, like so. And that'll allow me to know where I need to cut the bus to allow the current to go through the shunt. One thing I mentioned a second ago that I'd be doing was sending the sense lines through this 2-inch conduit back here. I actually forgot I installed this control panel, so I would actually go ahead and jump in. I need to put a grommet for these other wires down here. I'll jump in and go up through the 3/4 inch conduit because that has all my signaling lines, and it'd be a much less interference path to go through there. So clearly you can see I have my marks on the bus bar in the Sharpie, and that's exactly where I'm going to drill my holes. And I know between these lines right here is where I need to cut. So I'll go ahead and I'll unbolt it at the bottom and unbolt it here at the top, and go ahead and drill and mount my shunt at that point. And one thing that's going to need to happen is this fused link, this little guy right here, that goes for my voltage sensing and my power going to my control panel. I'm going to need to drill and tap another hole up here to pull off at that point, because I want to be able to measure all my current going in and out of my battery. So as you can see, I've got that shunt installed right here. It's bolted through 4 bolts.
I have the slit in the bus bar done. I didn't actually end up unbolting this from here because there's all these wires right here, and I wouldn't want these to go flying in any way toward any of the other bus bars. So because I have the standoff right here behind, it was fine just to leave it connected. So I have my sense positive on this end and my sense negative on this end, opposite of what direction the shunt was previously used in. And what that does is when I get a positive voltage reading, that means the batteries are charging and the current's going this way, and when it's negative, it's coming this way and discharging the battery. So that's pretty good for my graph. I'll know when it's on the bottom side of the graph going below 0 that we're discharging, and when we're on the top side of the graph we're charging. I also went ahead and got the grommet in the side of that control panel, got all the wires cleared up. I moved that one wire that was on that bolt to up here. Now there was only one mistake I made. I was originally going to put this wire right here on this, in this hole right here, but somehow I had a brain fart and forgot that the tap size for a 3/8 hole is not 7/16, it's 5/16, because 7/16 is actually bigger than 3/8. So extra hole there, that's okay. I can use that in the future for maybe another lug or something, and that's why I drilled it in that location. But yeah, I got all the wires rerouted through that grommet hole. Everything's pretty good here. Everything's tied into the batteries, and all in all, this part of things is complete. On the PLC side of things, I have the wire. It does come up through here with the rest, because this is high current, high inductive fields, right? It's going to have more interference than these wires. So that comes up and over, and it's this wire right here, and as you can see, installed in the PLC. And I went ahead and got it set up. This is my battery voltage graph. It's not actually working because my current transducer needs some adjustment, and I haven't gotten to that point yet. But as you can see right here at the top, right now we're actually charging at roughly 28 amps. And this voltage is actually incorrect as well. If you see, it says 51.8 volts here on the inverter. We have pretty much 54 volts, so it's a little off. I need to do some adjusting, but no big deal there. And this graph isn't plugging in. As you can see, there's a red line right here across the bottom. That's supposed to be the amp reading. I'm trying to get the amp reading, 0 amps, to be at the middle of my graph, and have 100 amps be the top, negative 100 amps the bottom. Or I could probably do, negative 200, 0, 100 somehow. But I want to figure out voltage, so I have voltage overlaid too. So I can see the trend of how, as the battery voltage goes down, the current draws going up. So some figuring out to do on the PLC there, but all in all, things are going pretty good with this. As, like I said, it's reading the correct current, and that's pretty interesting because most people don't use these for anything other than temperature reading, and here I'm using a temperature I/O module for amperage sensing. So the really cool part is I have 3 more channels I can take advantage of, which means I can have up to 4 shunts. I just need the correct shunts, and can go from there. So there's still plenty of future expansion on this system, as always. So yeah, guys, if you enjoyed today's video, be sure to leave a thumbs up, hit the subscribe button. You've been watching High Tech Lab today, and don't forget to check out my second channel, link in the description. It's called High Tech Adventure, and on that channel I put some less on topic with the off-the-grid stuff, but more on topic for what I do on like a day-to-day life, whether that be in the sheet metal shop, fabricating, that kind of thing. So check it out, links in the description, new channel I got going. Other than that, guys, stay tuned for more awesome videos like this. It's been fun making this video. I'll see you in the next one. Bye.